Thank you very much for attending this seminar. My name is Ryo Takeda with Keysight Technologies. Today, I'd like to talk about a new product, PD1550A, Advanced Power Device Dynamic Analyzer that you can use to measure power module dynamic characteristics. The power modules have varieties of variations, and they are very, very popular and used in varieties of applications. Right? But it is important to characterize the behavior of the power module to use it in your circuit. However, it's not so easy to characterize dynamically of those power modules. First of all, it has high power density, like shown in this slide. I mean, on the left-hand side, usually you have multiple chips in the power module that can increase your current. And also, these days, the voltage required for electric vehicle is increasing. Normally, it was 400 volt, but it's increasing up to 800 volt in order to reduce the charging time, for instance, while keeping the current lower. But current is already high, even for the electric vehicle powertrain, like 400 amps. But if you use the wide band gap power module, which runs very, very fast, you may want to capture the current with a very high bandwidth. So it's not so easy to characterize the power module. And because of its high power density, safety testing is another important challenge. The other thing which makes the power module characterization so not so easy is its configuration. Normally, power module comes with the configuration like 2-in-1, 4-in-1, 6-in-1, and so forth. And that contains the half-bridge configuration. So unlike the discrete device, you have to evaluate not only the low side FET, but also the high side device. And it's not easy because the AC line in the middle is moving up and down with a high voltage amplitude, like 0 to 800, with a very, very high frequency. And therefore, you have a common mode noise affecting the measurement of the high side gate voltage. To characterize the gate voltage at the high side accurately, you need to have a good common mode rejection. And not only common mode rejection, but also bandwidth is important. And another important thing is the low noise. And there are more challenges. There are varieties of power modules with different form factors, as shown on the left-hand side of the slide. And you need to have a nicely created interface board or something which has the minimum parasitics, which is not so easy to make. And to make the in-depth characterization, the thermal dependent measurement or temperature dependency characterization or characteristics with various gate resistors should be included. But both takes long time to perform the test. And also, if you want to change the gate resistor, normally it's the small, tiny SMD resistors. So you have to solder and unsolder the resistor, which is cumbersome and takes long time to complete. And the operation of the test is another headache, I think. Yeah, since it requires safety consideration, as well as the necessity of having the in-depth knowledge, like device physics. And if you have lots of measurement results, you have a problem managing the data and analyzing the data. So there are lots of challenges for characterizing the power module. And Keysight is the test and measurement instrument company. And we developed a few key technologies to solve those challenges and then put them together to come up with a new product called PD1550A, Advanced Power Device Dynamic Analyzer. And I will explain the few key technologies using the next few slides. But we believe that we can help our customers to reduce the time to market with this new product. The first one I want to talk is the high current measurement capability without sacrificing the bandwidth. So you have a few choices for the current sensing. We selected a coaxial shunt to make the current measurement because of the higher bandwidth, unlike the other alternative like Rogowski coil or Pearson probe. At least the coaxial shunt should give you the best performance in terms of the bandwidth. And in the graph, you see the current going up more than 400 amps. And the system can go up to 1,000 amps. And the measurement-wise, it can go up to 2,000 amps. Should have the sufficient current capacity for the most of the power module. And so we decided to use the coaxial shunt for current sensing. But the one thing we noticed by getting the coaxial shunts from supplier, there are good shunt and the bad shunt. The bandwidth is pretty much spread over the wide frequency range. If you are lucky, you get the good one, like 300 megahertz. If you're unlucky, you get 25 or 30 megahertz bandwidth. So you have to do something for this if you want to make the measurement accurate, right? And the bandwidth difference indicates the insertion inductance of the current shunt has a problem. So what we do is to characterize each individual coaxial shunt using network analyzer and measure S parameter, and use that information to eliminate the influence from the insertion inductance. Then you have pretty consistent test results, as shown in the right-hand side of the slide. So this is how we make the current measurement repeatable and reliable. Okay, and many people talk about the high side FET testing, very, very difficult. And it is difficult. And some people use the commercially available optically isolated probe. And you get the good measurement, as shown in this slide. On the left-hand side, you see yellow trace and blue trace. Yellow trace is from the commercially available optically isolated probe. So you don't see the influence from common mode noise because it has a good common mode rejection capability. And so we developed the similar technology what we call true pulse isolated probe technology. And it's plotted with the blue trace on this graph. And you see it doesn't get the influence from common mode noise. And if you look into more detail on the right-hand side of the graph, the noise performance of our capability or new technology is actually superior. So we believe we have the best performance for the high-side VGS testing with our new technology. All right, so PD1550A is kind of a standard off-the-shelf type test instrument or tester. And so you can use most of the features without doing any work. But because the power module has different form factors, one thing has to be custom, which is interface board. So there are lots of know-how and expertise necessary to make this interface board. So Keysight makes the tailored interface board for your power module. And as you see on the upper side of the slide, it is solder-less contact. So you don't have to use soldering to make a good contact. And also, yeah, the layout is well sorted out. So layout is optimized to make the parasitic minimum. And also, we have the standard gate driver board, which has a wide range, like from minus 28 volt to 28 volt. And one thing, under the bottom side of the slide shows the replaceable gate resistor module, which is very, very tiny. And since it has the small gate resistor, I mean SMD type gate resistor soldered on this power module, and you can just change this gate resistor module to a different value to change the gate resistor. And changing gate resistor is very important to accurately or characterize the power module deeply. And both the interface board and the small gate resistor module have EEPROM or EEPROM mounted, and that has all the information like maximum allowable voltage, current, and the gate resistor value, and so forth. And its software automatically detects that those conditions or limitation. All right. And the last thing I want to mention is its intuitive and extensive test results management. The software is the same one as the PD1500 series, which have been used by many customers across the world already. And yeah, it has the fill-in-the-blank type test setup. So you can just fill in the test conditions like drain voltage, drain current, gate voltage high, gate voltage low. And actually, you can put the multiple parameters, like multiple values for the one condition, like output voltage. And then there are a few checkboxes. I'm not sure if you can see it clearly, but on the left-hand side, you see the interface for this test software. And you see the checkbox upper in this black photo. And you can check what kind of analysis you want to perform, like extracting switching parameters or drawing switching locus or doing gate charge measurement, et cetera, and then click start button to perform the measurement. Then the system will do all the work from measurement to analysis, like drawing switching locus, extracting switching parameters, capturing oscilloscope traces. One interesting feature for this one is high power IV curve. So normally, IV curve is taken using curve tracer or like a power device analyzer. But power device analyzer or curve tracer is limited in terms of the power, energy. So you can get the very low voltage with a very high current, or very high voltage but very small current. You cannot get the characteristics where you have a high voltage and high current, right? But double pulse test is very convenient and good because you have a very fast pulse. So energy doesn't matter. And using the swept data, like sweeping the voltage, sweeping current, and you get the multiple test results from a double pulse, you can draw the high power IV curve, which is important for especially for the wide band gap device where you have short channel effect. So current doesn't get settled, but keeps going on or getting higher over the voltage. So that type of data can be utilized to make a good device model that can be used for simulation as well. All right, so let me summarize what I just talked today about PD1550. So yeah, we believe we can solve most of the challenges you face for characterizing the power module. We have a sufficient voltage range and current range. And yeah, we developed the two-pulse isolated probe technology for high-side FET testing. And yeah, there are a couple of things I didn't mention. One is the thermal test support. So you can have a temperature-dependent measurement from a minus 40 C to 175 C. And also, safety is very, very important for this type of equipment. So we comply with the safety regulations such as CSA or UL. And we do have the test system, PD1550, at our booth. So yeah, please feel free to visit our booth. Yeah, we are very happy to introduce you the actual hardware and software and giving you the live demonstration. Yeah, so please visit at booth 150 in hall 7. Thank you very much for your attention.